kasih. And then the last, let me give the time to Pak Trikuntoro. He's the lecturer of Faculty of Mathematics and Natural Sciences. And yeah, time is yours.
Thank you, gentlemen. Oh, good morning. Please, my PowerPoint. Here, I think what I'd like to deliver is the idea or innovation about technology to cope with all experiment on big data, cloud computing, parallel computing. So I call the title is Institution Capacity Building in order to support solving nation problem with mini computer cluster. Okay, so in here, what is the background that we have, as mentioned by all of the speakers, that we have big data problem. Not only in bank, but also in tax office. And also, we know that there is available the Raspberry Pi technology, which is very, very small and it is lower power, so low power. So we need a wide experiment to this. Okay, so what we want to do is develop we call the Visangani. This is some character in wayang called Visangani. This is the one who powerful. He is a son of Arjuna. So I hope that this computer will be powerful as Visangani itself. And we are developing operating system, developing monitoring system, and also doing the performance test for the result. This is the Visangani. So it is distributed memory system using Raspberry Pi cluster. Okay, this is a parallel computer system based on Raspberry cluster. So actually, I call it innovation because it is the first one who developed. This is 32 processor and one as a master and 32 as a slaves. So the main objective of building the Visangani one is to create parallel computer model which is very small dimension, mobile, and green computing. It is the power is very low. And Visangani can be used to conduct research which need run in parallel and high-speed computation, including parallel algorithm development. The research such theoretical chemistry, high-energy physics, big data, data mining, image and video processing can be conducted using this equipment. Okay, this is the hardware specification. So a lot of cabling. This is in the process of developing. And then the operating system is using Raspbian. And this is the scenario, so all the architecture. And what we need, actually we try to test the performance of the system using overclock in memory and also in processor. And the result is very, very amazing because from what we know, this is the temperature, the highest, the maximum temperature is only 51 degree Celsius degree. So it's not big. And in the normal operation, the peak performance is about 16 gigaflops. But in the and it's only need 1010 watt, and then it is equal to 0.145 gigaflops per watt. And then big performance, if we do the overclock, then the performance will be 23.6 gigaflops, and the power consumption is 125 watt. It means that only 0.18 gigaflops per watt. Okay, so comparing with the other architecture, this is from Intel Core 7, Intel Core 5 and Intel Core 7. It is not too far behind, but in some certain point, this is better than other architecture. And then this is the roadmap of development. So actually what we want to try is in the future research, developing the operating system and monitoring system, developing software tools to enhance the utilization and performance, and combining with the high performance desktop equipped with GPU, and develop application for bioinformatics, big data, image and video processing, theoretical chemistry, and also financial engineering, and maybe big data also. And then I think that's all. Thank you for Innovation Laboratory. Thank you.
Thank you very much. We have time until around 11, actually, so time to discussion is open right now. Would you mind if there's a question, comments of the presentation of those 6 people? We invite you to give a comments or questions. Please let me know to whom. Okay, there is still no one. I think I should come back to Mr. Kaplan to explain more about big data analytics and artificial intelligence. If you have something to add,
maybe do you want to comment to my architect?
Or you can comment also to the presentation of each presenter here.
Oh, I think I'm mic'd already. So, okay. First of all, I'd like to commend you on the fantastic work that you're doing. In our world of big data analytics and AI, we actually champion initiatives that encourage custom-made processing architectures, because with the ready-made architectures that are out there that are commonly used and provided by the leading providers out there, sometimes they are not actually created to cater for specific problems, especially if we are looking into creating, as for instance, without going too technical on it, clustering model. It will be very difficult sometimes to use it on a ready-made, out-of-the-box infrastructure or architecture. Whilst when we have a custom-made architecture like this one, we can easily tweak it in-house and actually have systems that run much more efficiently, faster, and can handle much larger volumes of data. So I'm a big fan of this type of architectures. In terms of AI and it's using big data analytics, I mean, AI is back again on the mainstream, forefront of mainstream media because of recent advances in artificial intelligence. Artificial intelligence itself is not quite new. However, we've reached a moment in human development or in modern history where a major bottleneck or major famous bottleneck that AI systems suffer from before was the lack of data. We live in a time now that data or the lack of data is not a problem anymore. In fact, it's the reverse problem. We have too much data and we need to find the various ways to process and filter this data. However, the systems themselves are yielding and producing much better results, because when you have smaller data sets, the sampling, for example, happens on a homogeneous level, meaning that you sample at regular time intervals, whilst most AI systems, even the ones that were produced and created since the 70s and 80s, had the assumption that the data sets that we have are built on heterogeneous sampling, which is sampling at irregular time intervals. Just to give you a practical examples, in financial markets, AI has been used for a long time to try to forecast the stock markets. It did not work quite well because when we dealt with low frequency data, we had homogeneous sampling, so we sampled at regular time intervals every day or every week or every month, and the systems did not produce very good results. However, as storage capacity increased, as data volumes, varieties, and velocities have increased, we have larger data that's coming at higher speeds. It is thick data, so it is sampled at irregular time intervals. It's actually sampled depending on the observations in the market. So we can have a sample now, the next one after 7 seconds, the next one after 17 seconds, and then the one after that after 2 seconds. So that form of volatility or heterogeneous sampling actually fits very well with the way artificial intelligence systems can handle data in general. Just giving an example, adaptive neurofuzzy inference systems or systems that are goal-oriented adaptive models. So the goal is to predict the market. We are predicting it on a high frequency level. The sampling is heterogeneous, and we can in a much easier way identify cycles and patterns in the markets much more than ever before. And it's all thanks to the ways that we are currently handling the data at, which is in a much more faster way. That's one way. Coming back to artificial intelligence as well, and the previous points that I've mentioned before, which is moving from data to information to knowledge to understanding to wisdom. I mean, we're reaching also tipping points in there whereby we're creating AI systems that are moving from narrow intelligence, or traditionally AI systems have only exhibited intelligent behavior in the sense that they would beat the world champion at chess, or they would beat the world champion at checkers, whilst in reality is just exhibiting intelligent behavior because it's doing some very fast form of data processing, computation, analysis, and will be able to choose the most optimum move. However, moving out of these narrow forms of intelligence and moving to wider intelligence, historically, AI systems have struggled with doing some of the basic functions that humans find very trivial to do, such as making a cup of tea in a kitchen that you've never seen before. We find it very easy. We just go find the cupboard, open it, get the tea bag, put it in the cup, and add hot water. AI systems, even the most sophisticated ones up to until 2 years ago, found that a very difficult task to achieve. However, with the advances of data processing or big data analytics, and as I said, moving from knowledge to understanding to wisdom, AI systems are finally realizing something that even humans struggle with. For example, knowledge is knowing that tomato is a fruit. Wisdom is knowing not to add a tomato in a fruit salad, for example. And that's something that AI systems are finally starting to realize contextually because of the process of learning that is embedded in the creation of these AI systems. So historically, we looked at only exhibiting intelligent behavior. Now adding learning and deep learning, the systems learn from their previous experiences, identify patterns, know that if what they've done right, they should exhibit that behavior again. They know that if they got it wrong once, they should never do that again. It's very similar to the cognitive process of the human in general in reinforcement learning. Our brains subconsciously trigger 2 types of functions, a reward function and a punishment function. Whenever we exhibit the right behavior, we actually reward ourselves subconsciously. This is very similar to when you're riding a bike. If you do the wrong move, you fall, it hurts you. Your brain tells you you should never ever do that move again. When you go back on the bike and you're riding it again, you're going in a straight line, your brain subconsciously rewards you and says this is the movement that you should be doing. We use exact same models, albeit mathematically. We have mathematical functions that are reward functions and punishment functions that are embedded in the system. And the system will learn that if it exhibited the right behavior, predicting the market correctly, for example, or given the right recommendation to a customer on an e-commerce platform, and the customer actually chose that recommendation, it rewards itself using intrinsic mathematical formulas that are in there. All thanks to the advances in gathering all of these big data sets and then applying these AI or hybrid AI systems in order to achieve very acceptable results from a user standpoint. At SixCap, we actually employ all these methodologies. We beautifully marry big data analytics and artificial intelligence to produce various systems ranging from insight analytics on the market to business networking using apps like Schedule to measure someone's reputational currency from a behavioral analytics standpoint to actually looking at your healthcare data. So we apply that on across a large spectrum of products, but the backbone or the brain of the system, which is our AI framework or AI engine, RiseBall, actually uses all these methodologies that I've just mentioned. Sorry, I took a bit long.
Thank you. Pak Sikuntoro, would you like to comment something?
Thank you. I just like to add that my roadmap is to build in this end of the year is 64 processor, and then with one of Intel NUC processor, 8 Intel NUC, and then at the end of the year of 2017, I'd like to have at least 128 processor. I think with the 2 high-end PC with the GPU, and then also Intel NUC cluster computer. So hopefully it is the innovation to develop the tools for helping doing research, conducting research in big data, in bioinformatics, and also AI. I think that's all. Thank you.
Thank you. Yes, please
Hi.
mention your name and to whom the question is directed.
Yeah, good morning. My name is Ari from TV8. My questions goes to Mr. SixCap. Recent,
You mean Mr.
Yeah.
Kaplan?
Mr. Kappa, yes.
Yes,
I
Mr.
was,
Kaplan.
my bad, anyway, just to break the ice, boys. With the recent crisis, my data, my facts currently telling me algorithm trading contributes to the wipe-ups of many trillions of dollars. And algorithm trading begins when the Connecticut guys started forms long-term trading capital management. Now, my question is, how do you see it coming forward? Should we? I was interested in asking you about, because you have this hybrid model, because a lot of traders nowadays are relying on computer intelligence. Should we rely upon more algorithm, or should we just focus on our intuition? Thank you.
Thank you for the question. I mean, it's a fantastic question.